distributive property, FOIL. And again, we have a long title. This time we're going to focus on the vertex form of a quadratic. So here's our vertex form. Y equals a bracket x minus h n bracket squared plus k. And the reason we would use FOIL or distributive property in vertex form is to go from vertex to standard. So let's kind of write those out. This is our vertex form. And this is our standard. And to go from vertex to standard, we FOIL, or what's usually known as distributive property. Okay. Quick quiz again. Ready? We have FOIL. F-O-I-L. Tell me what they stand for.
First, outside, inside, last.
Nice. Whoops. Outside, inside, and last. Beautiful. Okay. So this might be a little harder to see because we're usually, when we talk about FOIL, we're talking about a set of brackets times a set of brackets. But it looks like I only have one set of brackets, so this other set of brackets is confusing. Also, what's different is we have a power of 2. So I want to try to think about this logically. How do you write this in expanded form, 5 to the power of 2? Do you know?
Yeah, 5 times 5.
5 times 5. So in other words, this power of 2 here means we take the base and multiply it by itself again, just like we had here with our 5s, right? So if the base is x minus 4, how do we write this in expanded form? Do you have any idea? We still have the x minus 4. What was the base here? X minus 4?
When the base is be x.
Well, the whole base is x minus 4. And remember with our expanded, we had our 5, right? So we wrote it out twice. So we do the same thing here. We write out the bracket twice. It's the same as if it was just one number. In this case, because the whole base was a bracket, we write the bracket twice. And plus 6. So now we can apply our first, outside, inside, last to our set of brackets. Okay, so let's do that. Which would be the first terms in each bracket here? What would we multiply first?
X with x.
Very good. Okay, so I'm just going to write the next part here. Y equals 2. We have our bracket. X times x is?
X squared.
Good. Okay, so we have x squared. Then what's the outside terms? What are our outside terms?
Wait, which one are outside?
It would be the farthest left and the farthest right.
Oh, okay.
So,
like still inside the bracket?
Yep.
Okay.
So what term is this?
X.
And what term is this?
Negative 4.
Perfect. So x times negative 4, which equals negative 4x. Okay. Inside terms, closest together in the bracket. What two terms are those?
So negative 4 and x.
Good. So negative 4 times x is negative
4.
Beautiful. And then what are the last terms in each bracket?
Like
the last term in each pair.
X and negative 4.
Well, there wouldn't be x.
Oh, the last. Okay,
yeah.
So negative 4 and negative 4.
Good. And negative 4 times negative 4 equals what?
Positive 16.
Good. Very good. Okay. So we've just used FOIL, and again, if you remember, that's kind of what they talk about a rainbow. You do the first one times both, and then the second one times both. It's the exact same idea, okay? We still have our plus 6 out here. So all we really did was deal with what's inside the brackets, okay? So we're going to continue. We need to collect like terms, and the only two like terms here are negative 4x and negative 4x. So when we simplify in our next step, we have 2 times x squared. And negative 4 gives us negative 8x plus 16 plus 6. So in the bracket, I can't really simplify any farther. None of these are like terms. This is the power of 2, power of 1, no exponent. I can't simplify farther. The next step would be to distribute our 2 on the outside. So we take the 2 and we multiply it into each of the values. So y is equal to, we'll write this part in red. 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. And 2 times positive 16 is positive 32. And we still have plus 6. Okay, so the last two terms are now like terms, and we can combine those together. So we get y is equal to 2x squared minus 16x plus 38. And lo and behold, we're in our standard form again. This is our a value, this is our b value, and this is our c value. So we have no more or nowhere else to simplify. Power of 2, power of 1, no exponent. And there's just our three terms, which is very similar to our standard form, or it's exactly what our standard form is for a quadratic.